All right, corn crack. So what I'm doing is the first page on from what you sent me. So the first three basically just said sketch the graph. So all you have to do that is you go to your handy calculator and you type in the function. So it would help if the calculator was on. Yeah. So all I did is I went to each of the functions. So this is the last one that I did just to show you. So you go to the y equals and you type in 2 to the x minus 1. You know how to do this. You go to graph, and then when it says sketch, make sure you get those intercepts. So this one right here, the intercept is at a half. Um, and I don't know if you want me to show you how to do that or adjust the windows or whatever, but that'll come up. So here the intercept again is a half, and an easy way to do that is make x equal to 0. So I showed you how to plug in. So it's going to be 2 to the 0 minus 1. So that's 2 to the negative 1, which is equal to 1/2. And again, you could just take these and plug this into the regular calculator like this. Let's clear all of that. So it's 2 to the 0 minus 1, and that gives you 0.5. So that gives you what the intercept is, just in case he asks you really to sketch it. All right, so the second, this is really where it begins. So it says solve for x, right? So I'm going to show you how to do this by hand first, and then I'll show you how to do this on the calculator to check your answer. So the first thing that you want to do is you want to get these bases to be the same. So right now you have a 3, you have a 9. A hint is always go to the smallest number. So the smallest number is 3, so you want to look and see if 3 to some power equals 9, and it does. So 3 to the second power is equal to 9. So I just rewrote 9 as 3 to the second. This comes down together, so it's x minus 2 is equal to 3 to the x. You leave this one alone because it's already 3. The second you have both of the bases the same, right? Those cancel out, and you are left with just plain old x is equal to, you do distributive property here, so that's going to give you 2x minus 4. The easiest thing to do is subtract 2x from both sides. That cancels out, and you have negative x equals negative 4. Divide both sides by negative 1, and you get x is equal to 4. I told you I would show you how to do this on the calculator just to check as well. So you go here to your calculator. Let's clear what's there. So under y1, I'll do this in blue so you can see it. Under y1, you're going to put exactly that. So under the y1, you're going to go 3 to the x power. And under y2, you're going to type this in. 9 to the x minus 2. So 9 to the x minus 2. And then you're going to go to graph. And what you're doing is you're basically looking to see where the two graphs intersect. So that's the first graph. Somewhere there is a second graph. And you want to see where it intersects. So I see over here, they're kind of like overlapping, but the intersection is going to happen over here up at the top. So I want to change my window so I can actually see it. What the part that I'm missing to see is the y max. So I'm going to go down until I get to y max, and I'm going to be dramatic about it and just put 50 so I can see what's there. So that's the first one. That's the second one. And again, I still can't really see the y, but I'm just going to go ahead and adjust that window again. Maybe I need to be even more dramatic, right? So I want to go ahead and just make it like 150. Which basically what you're doing is you're allowing the window to actually, so you can actually see it. So the first 2 times I couldn't actually see where it actually intersected, but now when I changed my max, there you go. Somewhere over there is where it intersects. I'm going to go to second. I'm going to go to calc. I'm going to go to intersection, and I'm just going to hit enter, 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 and it's going to give me the value. So I have 4 and 81. I don't care about the y because as you can see here, all I care about the x's, and x is equal to 4. The other way to do it is, which you know from algebra, is basically to go to the table and find out where the y1 and the y2 are the same. Anyway, moving on. All right, so I'm just going to try to do these algebraically so you can get the hint of what to do. So here again, the base is 2, here it's 4. So I know that 4 is going to be 2 to the second power. The x plus 1 comes down. This is going to remain as 2 to the 3x. Again, the bases are the same, so I'm going to cross them out. And I bring down the 3x is equal to distributive property again, so that's going to be 2x plus 2. And then I subtract 2x from both sides. So I'm going to get x is equal to 2. There's your solution. This last one right here, very similar. Now look, the bases are already the same, so I could just cross them out. So I get x minus 1 is equal to 3. Add 1 to both sides, and you get x is equal to 4. And again, you could check all of these on the calculator. All right, next. An investor purchases a blah, 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 you could read. So this is how much it's being purchased for, paying 10% annual interest. So interest means that the amount is going to go up. Compounded semi-annually, that's important. And it says find blah, blah, blah at the end of 8 years. All right, so I know that the formula for this is A equals P, parentheses 1 plus R over N to the NT power. And so now all we're going to do is plug in stuff. So we know that our purchase is going to be for 12,000. It's going to be 1 plus the rate, 2 places to the left, is going to be 0.10 divided by the n, the number of times this happens. So semi-annually means that it happens twice a year. So that's what's going to go at the bottom. And this is going to be to the NT. So it's going to be 2 times, and then the time is 8 years. So all of this is just literally just going to go into the calculator. All right, so I have 12,000 parentheses, and I'm going to do 1 plus alpha y equals, gives me the little fraction thing. So I'm going to do 0.10 divided by 2. I'm going to close my parentheses, and then that's going to be raised to the 2 times 8 power. I hit enter, and this is the amount that I have, 26,194. Find the amount received when the savings certificate is redeemed. So it's $26,194.50. 26194.50. That's a sucky 6. 26194. Whatever. So that's how much money it's going to be. I just want to make sure I type that in right. Okay, good. Next, so a firm tends to replace some of its present computers in 5 years, blah, blah, blah. So same concept, 25,000. We want to see 5 years down the line, paying 12% compounded monthly. All right, so very similar to the previous thing. First thing we're going to do is write down the formula, make sure it's easy to plug in. So again, 25,000 is our purchase price. It's interest. Yeah, well, investment, the rate is 12%, so that's 0.12 divided by, there's 12 months in a year. And then we are going to multiply it by n. 12 times the number of years is going to be 5. And so again, all of this just goes into the calculator. So let me go ahead. The easy thing to do here at this point is just to pull down what we had before and just replace stuff. I know, it'd probably be easier just to type it in again, but I'm a lazy person. So 25,000, it's 0.12 divided by 12 on the bottom. And over here, I'm going to go over to the top. I'm going to insert a 1 for the 12, and it's not 8 years, it is 5 years. And I get 45,417. All right, so 45,417, 45,417 point something, 42. And again, you're rounding this to money, right? So it's going to be to the nearest cent. Parents blah, 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 10,000, 8% annual interest compounded quarterly. So 8%, 10,000, 18 years is going to be what we have to do. So I'm going to go ahead, I should do the plugin. I'm not going to write the formula this time because I think you get the idea. So it's going to be 10,000 times 1 plus, the R is 8%, so 0.08 divided by quarterly, which is 4, and that's going to be to the 4 times 18 years. You could take this, plug this into the calculator and get an answer. All right. Write each expression in terms of a simpler log. So basically what we're doing is a simple logarithm forms. So you're taking these and you're splitting it. So reminder, multiplication changes into addition when we're expanding, and division changes into subtraction. That's our little like hint. Okay. So here I have multiplication. So I'm going to split this up. The log base 10 still stays the same. The first one that you see is 120. You could put parentheses around it. Times changes into addition. When you split it up, you write log 10 again, and then you put the second number. So the second one is 36. So there is your simpler log form. All right, this one right here. So we have an exponent. Exponents get kicked to the front. So it's going to be 4. It's still log base 3 of 3. There is your answer. This is next one right here. So we have times, times, and just like in the first problem, this is just going to expand log base a of 2 plus log base a of x plus log base a of y. That's going to be our whole answer for number 5. For number 7, I have a division and I have a multiplication right here. So I'm going to get log base a of x minus, and both the y and the z are on the denominator, so I'm just going to go ahead and put a big parentheses. So it's going to be log base a of y times changes into addition plus, and it's going to be log base a of z. So this whole thing is going to be the answer for number 7. You want me to go in order, so this one right here, again, same thing. The 5 gets kicked to the front, so it's going to be 5 ln of x. That's it. Got to box this one. This one right here, I have a times, so I'm going to deal with that splitting part first. So I'm going to have log base a of x squared plus log base a of y to the third, and then I'm going to do that power rule, and the power rule says that this exponent gets kicked to the front, so it's going to be 2 log a of x plus this exponent gets kicked to the front right here, so it's going to be 3 log a of y. This is our whole answer right there. Okay, here. So anytime I have square root of x, y, that's going to be the same thing as xy to the 1/2 power. Okay, got it? Okay, so I'm going to have the 1/2, and just like before, I'm going to take that 1/2 and I'm going to kick it to the front. So it's going to be the same thing as 1/2, and I'm going to go ahead and split this up. So I have times, which changes into addition. So it's going to be log base a of x plus log base a of y. So this is your whole answer. I just want to make sure I didn't miss anything on the bottom because you always yell at me. Okay, I didn't. All right, this one now, it says write each expression as a single one. So now I'm going to go the opposite. So addition changes into multiplication and subtraction changes into division. So here's our little like key. All right, so the difference again is now I'm condensing it. So addition again changes into multiplication. So I'm going to have a times. I'm going to have a single log. And this is going to be x squared, right? The 2 gets kicked. I don't know what's going on. Okay, I don't know what's going on. Getting up to date, blah, blah, blah. No, don't do that. Snooze. Go away. Okay. Hopefully it's still recording. Yeah, I think it is. Okay, so we have what happened here. So this 2 why is not writing?